Bitches love the gram.
Oh wait, shit. In my part, I will explain about the introduction, which is foundation in general. The lowest of structure is referred to as the foundation. Its function is to transfer the load of the structure to the soil on which is it resting. A properly designed foundation transfer the load throughout the soil without overstressing the soil. Overstressing the soil can result be either excessive settlement or shear failure of the soil, both of which cause damage to the structure. Thus, geotechnical and structural engineers who design foundation evaluate the bearing capacity of the soil. I'm going to explain about the foundation failure, which is the case study number 1, rare foundation failure of a building in Shanghai, China. The introduction. Generally, it is rare that a building in collapse due to foundation failure unless it is constructed on expensive soil. Initially, it was thought that a 70-meter section of the flood prevention with nearby Dianpu River might have triggered this building. But as the figure, the disaster happened because the block was laid alongside. The next one is the causes. The causes number 1 is an excavation of sub-level garage was made on the south side of the block to a depth of 4.6 meters without any support for the retaining walls. The second causes is the excavated earth was dumped on the north side to a height of 10 meters, which induced an uneven lateral pressure from both directions. Move to the summary. The rare foundation failure and collapse of the building in China was caused by excavated earth on one side and piled up earth and water table on the other side, exerting differential pressure on the piles. When the pile's capacity exceeded, the pile fell and the building toppled en masse, resulting in a rare foundation failure. It was mainly due to the result of careless excavation very near to the building for the purpose of providing underground car park. Engineers should take a note of the lessons learned from this failure and avoid such mistakes in future. The next one is summary 2. The first one, taking into consideration of proximity near to the river, proper design and construction method should be followed according to the IC to reduce the risk of failure. The second one, special materials and equipment should be used for safety purposes. The third one, careful site inspection should be conducted regularly. And the last one is engineers should precisely consider the geological properties, engineering properties, and environmental properties before designing any building. That's all from me. Thank you.
Case Study 2, Highland Tower Collapse, the tragic story of Malaysia. In 1993, collapse of Highland Tower in Kuala Lumpur, Malaysia resulted in 48 deaths according to the report of Maverick. One of the major causes of landslide was improper soil testing. The peripheral condition of site resulted in undermining. The failure of retaining walls under heavy rains was a contributing factor, causing a landslide that led to the building collapse. Causes: first, improper soil testing. Second, the peripheral condition of site result in undermining. Third is failure of rubble foundation. Summary of analysis and design method used by the building. This study concludes that it is recommended to perform human reliability analysis in slope construction to reduce the chance of error holistically. The finding also confirmed that whether the safety factor of the slope is high or low, there is always a possibility of instability if the probability of failure due to human uncertainties is not tackled in a logical manner. Summary of problem solving recommendation. First, investigate incident of flooding and mud flow prior to disaster. Second, quality and design, construction and maintenance must meet the specification.
Case study number 3. It's about failure in the existing residential building. So first of all, we go to introduction. Basic principle of a building is to unite all of the structure as a nation to carry and transfer the load all together and propositional into the ground. Foundation is a supporting link between the building and the ground. They will transfer the load from the wall, floor and roof into the ground. This foundation will act as support to interact load and force from building structure. Okay, so we go to causes. We have 4 causes. First is environmental factor. Second is design deficiency. Third is construction fault. Fourth is lack of factor. First summary. This study concludes that it is recommended to perform human reliability analysis in slope construction to reduce the chance of error holistically. The finding also confirmed that whether the safety factor of the slope is high or low, there is always possibility of instability if the probability of failure due to human uncertainties is not taken in a logical manner. Number 2. First, the location of the crack is as important as the physical appearance. Foundation movement often result in crack at weak points, such as windows opening and doors. Second is foundation movement tend to distort opening and often causes door and windows to stick. In some cases, the distortion may also affect partition, ceiling, floor, and the roof.
Hello, I'm Nadwatul Fariza. Today I will present about our case study 5, Stabilizing the Leaning Tower of Pisa, the evolution of geotechnical solution. So first, introduction. On Thursday, 7 September 1995, ground freezing was being carried out around the Tower of Pisa when it began to increase its inclination dramatically. In one night, it moved southwards more than it would normally have moved in a year. The freezing operation had to be terminated, and for 3 weeks desperate efforts were made to save the tower. This period has come to be known as Black September. The paper described how and why the Pisa Commission got into this predicament and how it was resolved. More generally, the paper traces the evolution of some of the ideas and schemes for stabilizing the tower that were put forward by members of the commission, unraveling the history of tower and understanding the mechanism of its movement proved crucial to developing the successful stabilization measure. A detailed technical description of the project is given by Berlin at AL.1. Next is causes. Many soil borings around and even beneath the tower show that the surface of layer is disshaped. due to the weight of the tower above it. From this, it can be deducted that the average settlement of the tower was at least 3 m, a graphic demonstration of how very compressible in the underlying soil. Summary: construction of the tower began in August 1173, and by about 1178, it had progressed to 1/4 the way up the fourth story when work stopped. The reason for stopping is not known, but had to continue much further. The soil in layer B would not have been strong enough to carry the load, and the tower would have fallen over due to a bearing capacity failure of the foundation. Work recommenced in about 1272, which time the strength of the clay had increased due to consolidation under the weight of the tower, although this would not have been known. By about 1278, construction had reached the 7th level when work stopped again. There can be no doubt that had the tower been complete at this stage, it would have fallen over. About 1360, when the further consolidation of the underlying clay had taken place, work on the belt chamber commenced and was complete in about 1370, nearly 200 years after commencement of construction. Last is summary 2. From early on the work of the commission, we had been giving to the possible long-term geotechnical stabilization measure. In January 1991, the commission discussed the concept of what was termed controlled differential subsidence at slightly reducing the inclination of the tower, thereby simultaneously reducing the foundation and masonry stresses. At that time, 3 possible ways had been identified of doing this. First is the north-facing slab being strongly advocated by Professor Leonhardt. Second is drainage of the marine clay on the north side by means of electro-osmosis. Third is drainage from the intermediate sands beneath of the north side by pumping from the wells. Okay, that's all. Thank you.